Bulletproof Radio, a state of high performance.
You're listening to Bulletproof Radio with Dave Asprey. Today's cool fact of the day is that heart cells in a Petri dish will beat in rhythm even if they're not touching. They must have some way of communicating with each other. Wonder what it might be. It's not chemical. Before we get into today's show, if you haven't tried the new coffee roast profiles that we have for you, you are missing out. There's a variety pack now where you can get the Mentalist, which is a medium dark. You can get French Kick, which is a darker but not burned to a crisp, nasty kind of dark, and the original roast, all three of them. It's really amazing what you can do with ultra clean coffee that doesn't inhibit mitochondrial performance with the presence of nasty toxins that come from mold. So if you've been making some sort of knockoff coffee and you haven't felt what it's like to have coffee that doesn't slow you down while it also speeds you up, give it a try just one time and you'll feel the difference. I bet on it. Today's guest is someone I met more than 10 years ago, when he first spoke at the Silicon Valley Health Institute, the nonprofit that I run in the anti-aging field in Palo Alto. He's one of what I guess you could call him the fathers of epigenetics. And epigenetics, if you're new to the show, is this study of how our genes are changed by the environment around us. I cited his work quite a lot in my first book, The Better Baby Book, and also a little bit in The Bulletproof Diet. And by now, if you're a longtime fan, you might be guessing that our guest is Dr. Bruce Lipton. But if you haven't guessed, now you know. Dr. Lipton, welcome to the show.
I am so happy to be here. And I happen to bring along my own mental coffee, your coffee. Thank you so much. You know, and I've been using it for a year and a half because I got on a ketogenic diet, and it's wonderful because I can have a cup of coffee in the morning and not even be hungry until mid-afternoon. And for a guy trying to lose weight, that was magic. So thank you very much.
You're so welcome. And for people listening, that just blows me away. Like, you'll hear in a minute here what Bruce Lipton has done with his career and with his knowledge, and to find out that someone at his level is drinking my coffee actually just makes me feel good. Like, it's really cool. So
well, that makes two of us feel good.
And I did not know that. Like, we didn't set that everything.
No,
we just got on the phone. I'm like, really?
Yeah.
So now, Bruce, you have a degree in biology and a Ph.D. in developmental biology. You studied muscular dystrophy, cloning stem cells, and in 1982, you started studying quantum physics, back when we were just figuring out quantum physics actually sort of mattered, really. You discovered that cell's outer layer had its own intelligence, kind of like an organic microchip. And you went from being an atheist to believing that the way cells behave and function are proof that God exists. You've had a pretty big path where you studied cellular biology, you studied quantum physics, and you realized there was something going on that you didn't expect. Tell me about your path. That's pretty profound.
Well, the most exciting part about it was that my research on cloning stem cells, which I was cloning stem cells back in 1967. And it's interesting because back in 1967, there was maybe only a handful of us in the entire world that even knew what a stem cell was.
That was way before it was cool.
Oh, yeah, and it was like, oh, look, secret research. That wasn't secret, it's just nobody knew about it. And now it's a global awareness about the nature of stem cells. And stem cells are embryonic cells. We call them stem cells because once you're born, I can't keep referring to them as embryonic cells because they're still in your body and you're born. So we changed the name. And I said, but consider this, a stem cell is an embryonic cell, and why is it relevant is because no matter how old we are, every day we lose hundreds of billions of cells, normal attrition. Just normally, they die, and you have to replace them. I mean, the entire lining of the digestive tract from your mouth to your anus, the entire lining of that is replaced every 3 days. And so there's a point that says, well, if I'm losing hundreds of billions of cells every day, where am I getting the new ones? I say, these stem cells. So this, for me, was real interesting because a stem cell is a multi-potential cell. But my whole world turned upside down when I was cloning them, which meant I put one cell in a dish by itself, and then it would divide every 10 or 12 hours. And after a week, I'd have 50,000 cells in a dish. But the most important part was every cell was genetically identical to every other cell. They came from the same parent. So I have 50,000 genetically identical cells. And this one experiment changed my entire career, and that was I'd split these genetically identical cells into 3 different Petri dishes, and I changed the chemistry of the culture medium. Just a little bit in each of the dishes. So genetically identical cells, but slightly different environment. And the relevance was, in one dish my cells form muscle, in another dish the cells form bone, and in a different culture medium the genetically identical cells form fat cells. And here I am teaching in medical school that genes control life, and then I walk into my laboratory and it's like, no, that's not true.
Wow.
The genes did not control the fate of the cells. It was the environment that controlled the fate of the cells. And it became important just to let people know. You say, well, that was really great. You were doing cells and tissue culture, big deal. What about me? I'm a human being. And I go, okay, here's the joke. The joke is this: when you look in the mirror and see yourself as a single individual, the truth is that that's a misperception. You are made out of about 50 trillion cells. The cells are the living entity. When I say Bruce, that's a name for a community of 50 trillion cells. So the jokey part is a human is a skin-covered Petri dish with 50 trillion cells inside, and the culture medium is blood. And I say, well, what's the relevance? I say, it doesn't make a difference if the cell's in a plastic dish or the skin-covered dish. The cell's fate is determined by the composition of the blood, which represents the environment for the cells. And as we change the composition of our blood, we change the fate of our cells. And I say, well, what controls the composition? And I say, well, the brain is the chemist. And I say, yeah, but what chemistry should the brain put into the blood? And then I go, you now jump up one picture and say, whatever the mind is perceiving, the brain will take that picture and break it down into complementary chemistry. If you are looking at the world and you see joy and happiness, then the brain will take joy and happiness into chemistry such as dopamine, pleasure, and put this into your blood. And I go, why is it relevant? Because the chemistry of love and joy is a chemistry of health and happiness and growth. And yet the same person could look at the world and be afraid and have fear. And I go, well, what's the consequence? I say, well, that love chemistry and happiness chemistry is not going to be coming out of a brain that's interpreting fear. It will release stress hormones and inflammatory agents. And I say, oh, the blood chemistry, which is the culture medium, changes in regard to what mind picture we have. In other words, how do you interpret the world? And if you interpret it in a very positive way, then you release chemistry that enhances growth. But if you are afraid or nervous or in fear about the world, then you secrete chemistry that puts you into protection. And I say, well, this is profound for this reason. Growth, by definition, is being open. Take things in, assimilate. That's how you grow, okay? And then I go, okay, that's really cool. But what about protection? I go, protection, close things off. Wall yourself off. And I say, well, why is it relevant? I say, growth is open, protection is closed. You can't be in growth and in protection at the same time. And you say, yeah, but do I need to be in growth? I'm old. I go, yes, every day you have to replace hundreds of billions of cells. So if you look at the world in fear, then by definition you're going to shut down the growth of the system as it walls itself off in protection. I say, well, this might be good while a saber-toothed tiger is chasing you, but if you are in continuous protection, then by definition you are in continuous inhibition of your growth. And this is the biggest part. The stress hormones from a protection perception shut down the immune system. And so I say, oh my God, you have 2 strikes against you right now. One, if you're in fear, you've shut down the growth. Yeah, but I have to grow every day. So how long can I shut down the growth without having a negative impact? And I say, not too long. And then I also say, and stress hormones shut off the immune system. It's not to punish you. It's just that the immune system uses a lot of energy. I mean, if you've ever been sick and laid in a bed, you got no energy. And I go, yeah, but the immune system, when you're being chased by a tiger, is not really relevant. At that moment, it's like, oh, that's fine. I'll deal with it later. I got to get out of here. So the body allocates all the energy in fear for fight or flight. And it shuts down all functions that are using energy that are not going to help you, like growth and the immune system, as long as you're in fear. In the old days, it wasn't a problem because you'd run away from a saber-toothed tiger. And once you're free, then the system would cut back and then we'd be back in growth.
I have a bit of a confession to make. The definition of biohacking that I wrote is, I just want to read this to you, or I know it from memory because you're going to laugh. It just ties in with what you said. It's changing the environment around you and inside of you so you have full control of your own biology so you can do whatever you want to do, right? And
the answer is yes.
Well, I knocked that off. I mean, that is a restatement of your work, and I mean, I credited you with it. But seriously, the whole biohacking movement, the stress response you just talked about is the environment inside yourself, and there's a chemical environment too, and then the environment outside of you, the things you eat and the things you do, and breathing and all that kind of stuff. Those are core control levers, and the mechanisms for that are things that you first teased out because of those 3 Petri dishes, which is a pretty profound thing.
It was for me. It changed my entire life.
You took anyone who disrupts a whole industry or a whole paradigm always gets people complain about it a lot. You get a lot of arrows in your back for it. Yeah. What happened when you first said, guys, it's what's in the Petri dish that's not a cell that matters? Like, what did the scientific community do?
I love it because there were 2 different responses. The first time I'd left the university because I realized what I was teaching medical students was completely wrong, that we are genetic automatons. Because if you believe that, then you also believe this, that you are not in control, that your life is controlled by your genes. So I said, what am I teaching medical students is that we are victims of our heredity. Oh, you got a cancer gene or an Alzheimer gene, and all of a sudden you're going to have that, and there's nothing you can do about it because it's your genes. So we program people to be victims. And I say, why is that relevant? Because the moment you perceive you're a victim, you also say, I'm powerless.
Yes.
And when people say they're powerless, they give up. I have no responsibility about my life because it's not me, it's my genes anyway, so it's not me. And the reality is, oh my God, that was completely wrong because the genes are not self-actualizing. Let's clear up because how many millions of people out there to say, oh, a gene turned on and a gene turned off and the gene controlled my life. And I go, first thing, that's completely false. The whole belief is false. A gene is a blueprint. I say, why is it relevant? I say, it is a blueprint. In this regard, you go into an architect's office and she's working on a blueprint. You lean over the architect's shoulder and you say, excuse me, is your blueprint on or off? And she'd look at you like, are you crazy? It's a blueprint. There's no on and off. I go, precisely. A gene is not self-actualizing. A gene has no ability to control itself or even know what it is or why it's there. We have given like this life to a gene that it's controlling us. I go, it doesn't control you any more than a blueprint. And the why is it relevant is because your mind is a contractor. And your mind will pull up the blueprints. And now we also know it can rewrite the program of the blueprint. It can change the readout of a blueprint. Every gene, by how you look at the world, every gene can create 3,000 or more different proteins from the same blueprint. It's like, whoa, that wasn't in our history. And I say, why? Is because you can come with healthy genes, and based on your interpretation of the environment, read them as cancer genes. So the idea is, we always say genes cause cancer. I say there is no gene that causes cancer. And it's really the environment that opens you up, and that is where the expression of cancer comes from. You shut down your immune system, you shut down your growth, you are interfering, you're throwing a monkey wrench in the system. So it says, no, wait, we're the ones that are powerful, not the genes. And yet the whole world has been programmed. I am a victim. And that's why I had to leave the medical school.
Isn't it true though, like the color of your eyes? I do know a couple of people who've changed the color of their eyes with weird interventions, usually very spiritual, meditating people. But there are some characteristics or some diseases, like if you've got both of the alleles, you're pretty much going to get that. I always felt like it was, there's some percentage of like, you're kind of screwed if you've got that. And
yeah. Let me give you a number, because there is a number, and it says less than 1% of disease is directly connected to genetics.
I believe that.
That's a real number. And I say, well, then automatically it says, well, then if only 1% is connected to genetics, the question you need to ask is, what's the 90-some percent? And that's where we start to find the environment, and the information in our interpretation of that environment is what is totally controlling us. So even the American Psychological Association has recently come out and said 90% of doctor visits are directly related to stress. And all of a sudden it says, we've been blaming our bodies, frail, vulnerable. Oh, we're such weaklings, sugar's going to kill you. Bacterium's going to kill you. And it's like, you have a misinterpretation of who we really are. We are so powerful, except if it's based on belief and perception. All I have to do is tell you and have you believe that you're not powerful. And since it's based on belief, then if you believe you're not powerful, you're not powerful. And if you believe you're going to get a cancer, you can get a cancer with no genetic foundation for it. As a matter of fact, less than 10% of cancer is even connected to genetics. So there's an upheaval of our world that takes us from, I'm a victim of my genes. No, the new science is you are a master. You are the one who selects and modifies and controls the readout of your genes. And when you understand that, then it says, oh my God, I am powerful. And I go, yeah, you're really powerful, except your belief perhaps says you're not.
So then what do you think about the groups who are promoting, breast cancer awareness, let's say?
It's promoting awareness, which is what? I said awareness is really what's controlling our biology. So when you have an awareness of, oh my God, I could get this breast cancer, and you get someone like Angelina Jolie, and she has a double mastectomy because she says, I am going to prevent my breast cancer gene from giving me cancer. My mother died, my grandmother died, so I don't want this. I'll remove my breast. And then it turns out there's the breast cancer gene, BRCA1, doesn't cause cancer. And I say, what do you mean? I say, 50% of the women that have that gene never get a cancer. Now, you have to stop for that moment and say, you mean I can have the gene and not get the cancer? And I go, 50% of the women don't. So what's the point? The gene itself does not cause cancer.
It's your lifestyle. It always was.
Yeah,
I'm torn about that. I'm all in favor of research on cancer, but when you promote worry about cancer, you're not doing it right. And
no, as a matter of fact, everyone out there is, the placebo effect. Placebo effect. I am sick. The doctor says, this magic pill is going to heal you, and you take the magic pill and you get well, and you go, thank God for the magic pill. And then you find out it was a sugar pill. I say, why is that relevant? The answer was, well, the sugar pill didn't do anything, so where did the healing come from? And the answer was, your belief in the pill is what created the healing. And everybody goes, oh yeah, placebo effect, positive thinking, blah, blah. And I go, yes, that's true, but what people have left out, the average person on the street, is unaware of what is called the nocebo effect. I say, what's that? And I say, it's a negative belief. And you say, what's the consequence of a negative belief? I says, it's equally powerful to a positive belief in controlling your life, but it works in the opposite direction. A placebo is a positive belief that can heal you. A nocebo is a negative belief that can actually cause any disease, just the belief, or it can even kill you. People can be scared to death. A fear can kill them. And so I say, why is it relevant? It's like, well, we always focus on, hey, do some positive thinking. It's like, yeah, more important is stop the negative thinking, because the negative thinking is manifesting as disease.
I quit watching the news a long time ago.
Thank you.
It's actually almost required if you're going to live in a state of high performance, because it messes with your biology. Like it is not okay to sit there and just worry and see the same crap, negative stuff just sprayed around over and over. And I on Facebook go in and say, like, show me less posts like this. Like, honestly, I don't need to see 500 posts about whatever latest bad thing happened to 14 people.
Yeah.
Because I can do math, right?
And it's very interesting because all you have to do is recognize this. If I want to simplify the biology, I simplify it the easiest way, and it goes like this. Most people are familiar with paint by numbers. That was when we were kids and we get an outline of a picture and it's all broken up in little outlines and there's numbers in the little squares, and then there's a paint kit with a number, and if you take that paint and fill in the squares, and as soon as you fill them all in, you're Picasso, you create a masterpiece. And I go, the simplest understanding of life is paint by numbers in reverse. And I say, what does that mean? I say, first you put a picture in your mind, and the brain breaks down the picture into numbers, but the numbers are not paint, the numbers are neurochemistry, which adjusts the body like paint and turns the body into the image that was held in the mind. So first you put a picture in your mind, healing, cancer, you put the picture in, the brain takes the picture, converts it into chemistry. When it releases that chemistry in the body, it creates a three-dimensional image of the picture you just had in your mind. So if I have a fear, I go to a doctor, and the doctor gives me a diagnosis of terminal cancer. It's like, my whole mind has visions of cancer, and my God, I'm going to die in 3 months, like he said. And I go, what does that mean? I said, you've taken a picture, a negative picture, with death, and you have now put this picture in your mind. I say, what's the function of the brain? Take that picture and turn it into chemistry to manifest the picture. So all of a sudden it says, I can get the cancer just from having a diagnosis of having a cancer, even if the diagnosis was completely wrong.
So that raises a couple of questions. You talk about turning it into chemistry, and I'm thinking back to the cellular biology thing and something that happens when we're making, say, citric acid or any one of the other chemicals that we make in fermentation vats.
Yes.
A lot of people don't know this, but what they do is they genetically modify, usually aspergillus, which is a type of fungus. They put it in a culture medium with some corn or sugar or whatever, but then to make it produce, they change it so that it'll produce whatever chemical we want as its toxin. And then to raise the toxin producing level, they use microwave radiation, they heat and cool it, and they vibrate the vats. Basically, they stress out the cells.
Absolutely.
And they probably do some chemical manipulations as well, change the pH and whatnot. Well, if you take those things, it's not just chemistry. It's physical vibration, it's sound, it's light, it's electromagnetic frequency, it's temperature, and all of those things. How much of this communication, in your experience, is chemical versus all these other environmental inputs that are invisible but really important? Well,
it's a trick question with a trick answer.
Cool.
And the trick answer is simply this. In our Newtonian view of a world, we see two realms, a physical, mechanical realm, and an energetic realm, energy and visible energy. And in a Newtonian world, we say, they're two separate realms, and your body is made out of the physical realm, so if you want to change or adjust your body, you use physical things, chemistry. I go, cool. But in 1925, physicists recognized something very clear, and that was this. That thing that we call physical, our body. I said, yeah, it's made out of atoms. Those are particles. I go, yeah, but in 1925, they realized, physicists, when you go inside that atom, what the hell is inside? You go, protons and neutrons and electrons. Yeah, but what are those particles made out of? And that's where the new field of quantum physics came in. Because when they looked inside the electron, the proton, and neutron, there was nothing physical at all. It's an energy vibration. It's a vortex. It's a nano tornado of energy. And I go, why is it relevant? Because the quantum physics world does not distinguish between an energy and a mechanical world. They see they're all energy. The whole thing is energy. Relevance, the physical expression of energy, a human body, is totally integrated with the invisible energy in which we're immersed. I mean, all of us are sitting now in a field with telephone broadcasts, television broadcasts, radio broadcasts, solar energy broadcasts. I go, these in the Newtonian world, not relevant. These in the quantum physics world are primary. So let me give a quote. It's so simple, but it's like, we got to own this. And here's the quote.
Okay.
The field, which is the physicist's term for the invisible energy. The field, and this is a quote from Einstein, the field is the sole governing agency of the particle. Particle is matter. Mm-hmm. The field is energy. And what is the new physics? The field, the energy, is the sole governing agency of matter. And all of a sudden I said, oh my God, our whole science of biology and medicine has totally left out the energy field. And physicists come in and say, you can't leave out the energy field. It's fundamental in shaping everything else. So the answer to your trick question is, can I be affected by invisible energy fields and matter? And I say, they're both the same. You are indeed affected by the energy fields. And so why is that relevant? Because if you then go back and say, my brain is a generator, a broadcast of fields, electrical activity of the brain can be picked up with wires on your head. It's called EEG, electroencephalograph. I could read your brain function because the electrical activity of your brain connected to your skin, it's conducted, and I'm reading brain. And I go, that's cool, except for this. There is a new way of reading brain function. It's not electroencephalograph. It's called magnetoencephalograph. It reads more the magnetic field. I say, why is it relevant? This is so cool. The probe to read your brain does not touch your head.
Yes.
The probe to read your brain is out here. And I say, whoa, what does that mean? I said, you thought your thoughts were contained inside your head? I can read them out here.
They're spread outside your head, yeah.
So the idea is this, you are creating a field with your thought, and then I just put back the equation. The field is the sole governing agency of the particle, and then you realize, oh my God, my mind is a field generator, and that energy is 100 times more efficient in controlling your cells than our chemical energies. And so basically, your thoughts are shaping your physical biology. And that's where placebo, nocebo, it just differentiates positive thought, placebo, negative thought, nocebo.
So right now there's about 4% of the population, which is the number of hardcore skeptics that are out there. Right now, jumping up and down, they're probably driving their cars into bridges if they're listening to this, going,
yeah, I love that.
Ah! And they're getting all worked up over it.
But they have a belief system, and since it's based on belief, if you believe, as Henry Ford, I think, said, if you believe you can, or you believe you can't, you're right. And so I say, oh, the skeptic says, it can't be. And I go, well, for them, guess what? It won't work. It's like that because that's their belief system. So fine, stay in your skeptic world, but I'm opening up my world to, I know my thoughts change my genetics, and that's the science of epigenetics.
Yeah. At this point, the evidence is very clear on that front. The fact that people don't like the evidence is like, okay, you can yell and scream and use ad hominem attacks, which is basically you say, well, I don't like what you discovered, therefore you're a poopy head, which is, well, relatively dogmatic about it.
Been there, experienced that. I mean, I left the university after I realized my research conflicted with my teaching, and I was teaching incorrect information. I was teaching that we are victims, when the new science of epigenetics says, no, as I change my mind, I change my genetics. And I say, why is it relevant? You're free to change your mind any way you want. And since your mind is controlling your genetics and you are not a victim of your genetics, if anything, if you want to use the word victim, you're a victim of whatever thought is in your mind, especially if it's a negative thought. And I say, why is it relevant? I came back to the university after I understood the nature of how the environmental signals were being converted into genetic activity, which is the science of epigenetics. And I came back to my skeptical colleagues, which I left the university. I walked out with tenure. They were really pissed.
You had tenure too.
Giving
that's
up
amazing.
tenure. And I said, well, I want to come back because I needed a scientific audience just to hear my great idea, I thought it was. And so I got an audience with my former colleagues and the students in the anatomy department at the medical school in Wisconsin. And they gave me a lunchtime seminar, which is like people just bring their lunch because there's a social thing and some guy up in the front, blah, blah, blah. They don't really care. They're just eating lunch and enjoying themselves. So they gave me one of those. And the interesting thing was that I was just about finished with my lecture when I looked, and it dawned on me while I'm talking that nobody ate their lunch. They're all sitting there. They didn't even open the bags. They're sitting there looking at me with these big saucer eyes like I came from outer space. And I always thought this was a whole cool lecture because I was talking about the membrane and the physics and all that. They were so into genetics that whatever I was saying was way too far away for them. So what was the response? I get to the end of my lecture, and they're still looking at me, and I say, thank you very much. Yes, that was the response. It was the longest period of dead silence I've ever experienced in my life, and it was like totally silent. Everybody was uneasy. I'm standing in the front. I said thank you. They're just sitting in the seat, and one way in the back. He clapped twice, and I looked at him, and he clapped twice. But everybody else looked at him, and he put his hands down, and he stopped clapping, and then they all got up. All my former colleagues got up and walked out. Not one person said a word to me. And it was like, oh my God, I thought, am I crazy? Because crazy people believe in what they're doing. And I thought, am I crazy? Because I came in here with the most exciting view of this new science. And they looked at me like a coconut had hit me in the head. And they walked out. And I was like, oh my God, maybe I am crazy because I so believe what I'm into that I'm carried away by it. And I got nervous about it. And I went back actually to University of Virginia where I got my degree and spoke with my former people who were on my Ph.D. committee. And one of them was a world-class cell biologist. I mean, world-class. And I sat across from him, Lionel Revin. And I said, because now I'm concerned, because I thought, am my idea really crazy and I don't see where the problem is and everybody else does? So I said, Lenny, I'm going to explain it. I just want you to tell me what's wrong with it. And I give him my idea. And he sits back on his table and he goes, Bruce, it's not what we're thinking. I go, I know it's not what you're thinking. I want to know where it's wrong. It's too simple. I did exactly what you did. I laughed in his face, and he was like, okay, this guy's crazy, you know? And I had to catch myself and say, listen, Lenny, first year of graduate school, first class in graduate school, you guys taught me something called Occam's razor. And Occam's razor says the simplest hypothesis is the most likely hypothesis and should be considered before all others. And I laughed and I said, you couldn't have given me a better answer if I asked for one. I said, what's wrong with it? You said it's too simple. I go, okay, then by definition, this is the hypothesis that should be considered before anybody else's hypothesis. And then I ended up going to Stanford and a job interview. And I got there and it was like, I looked in the audience like, oh my God, chairman of pathology, chairman of dermatology, chairman of the biology department, chairman of the biochemistry department, the head of Genentech Research Institute. These are all genetic engineers. Mm-hmm. And my research and talk is, who cares about genes? It's really the environment. And so I give my talk like I did at Wisconsin in front of all these geneticists. And I come to the conclusion, I'm writing on the board, and I hear a phrase come from God knows where, and I thought, oh, that's funny. And I turn around, and I tell the audience after I'm writing my conclusion, I turn around and repeat just what I heard in my head, and I go, and therefore in the conclusion, if you believe that the genes are the end-all of everything, why, you're no better than a fundamentalist. Yeah, they didn't laugh.
Well, of course
I never saw such an apoplectic audience in my life. They were red-faced like, and they were all wanted to yell at me because each one wanted to vent, because at that moment what I did is I pulled the rug out of everything by saying, who cares about genetics? And they were like red-faced and they were yelling, and I was blown up against the backboard, they didn't want me to respond, they just wanted to vent. And in the head that gave me that little wonderful phrase that I thought was so funny, the next voice out of that detached voice was looking at this whole audience yelling and red-faced. The little voice in my head goes, this job interview isn't going well. And then at some point I kept slipping down until my belt caught on the chalkboard, the chalk tray, and said, that's about as low as you're going to go. And all of a sudden I started yelling back. I remember the first thing I said. The rest of it was stream of consciousness, but the first thing was simple. I said, there was life on this planet before there was DNA. So therefore, you can't start with DNA. There was already life here.
Explain that for people listening.
Well, the chemistry of our planet is an evolution of chemistry. Before there was life on this planet, there was only what is called inorganic chemistry. Minerals, rocks, salts, things like that. Life comes from organic chemistry. I say, yeah, but where the heck does organic chemistry come from? And he says, over time, the photons of light, Father Sky, interfaces and hits the Earth and etches the surface so that the chemistry at the surface picks up photons. Now it's energized chemistry. Well, that's called organic chemistry when it's got energy to it. So it's mobile, it's movable compared to a rock. That's just solid, solid, stable. But when you put photons of light, it's not so stable. Now it moves around. So where did organic chemistry come from? Sunlight hitting the Earth. Father Sky, Mother Earth come together and create a layer of organic chemistry at the surface. And that organic chemistry is the foundation of life. I say, yeah, but it didn't occur all of the chemistry at once. There were simple chemicals, organic chemistry, and then they became more complex chemistry. Point was, there were living forms of organisms before the complexity of DNA had been created. And so therefore, there was no real DNA and life had already started, which leaves you only to a logical conclusion. So, well, obviously DNA didn't do it. It wasn't even here. And so what was uniquely different about my Stanford experience after they all got apoplectic, after I yelled back at them, and I said, thank you very much, figuring, oh, here we go again. Thank you very much. And then they all applauded, which was like completely surprised. And the guy who brought me there for the interview gave me a list of all these prominent people. He said, after lunch, you're going to meet with these people. And I pushed the paper back and I said, listen, I think I irritated them enough. Maybe we don't want to waste any more of their time. And then he pushed the paper back to me and he said, no, you provoked the hell out of them. And they really like that. And that's how I got the job, because it was a provocation that made them feel like, well, okay, he's saying something.
Wow. Well,
yeah.
That says a lot about the integrity of that group of people. Right, like when someone pushes your boundaries, like, okay, I want to know more versus I want to run away, and that is a fundamental aspect of courage. And Galileo did the same thing many years ago, and he kind of got killed for that same thing. So at least that's illegal now, so you're safe that way.
Yeah, well, I mean, my Wisconsin audience, they were ready to kill me, and my Stanford audience was curious. That's what it was. And it was interesting because I came into a lab that was conventional, and after 4 years in that lab, when I left, they were already into the new area of research, epigenetics, in 1992, and that was the formal stage of the new science, epigenetics, that I was talking about. Wasn't even formulated as a science until after 1990. So I was there in 1967, so I had a good 20 years of working on something that science hadn't even owned yet. So I had to jump.
Now, you look like you have a suntan.
Yeah.
Now, is that because of this interaction between photons and matter in organic chemistry?
Oh, absolutely it is.
Me too.
And it's photonic energy that is really, the system runs on all this energy. As a matter of fact, if you could see a cell really close, the surface of the cell would look like a laser show.
It does
because
indeed.
It does.
Tell us more. This is awesome.
Well, because every time an electron is passed from one molecule to another molecule, as the electron is released, a photon of light is released. The whole biological system is on shuttling electrons. It's actually called electron train transport.
Yes.
And so why is it relevant? Well, all of the processes are involved with sending electrons, giving off photons, and so the whole thing glows. And it glows in all these different colors based on what the energy level that electron was coming from gives off a different photon of light. So at the level of a cell, if you could look at it, it would light up continuously like a laser show with lights going on, and that's just a secondary consequence of passing an electron from A to B, which is the nature of energy transfer in the system.
So that would imply that you can then add energy to a system using light.
Yes.
How familiar are you with that kind of work?
Well, back in 1960s, I remember that laser light in the red range in a certain vibrational frequency of red, way back then, was used to activate the healing response in wounds. And again, that was, weird people are doing it. Or,
yeah.
so photons of light were doing that, and bone healing was manifest through putting an electrical field around the bone.
Yeah, running
And
a
all
little
this-
current over it, right?
Right. So conventional biology is, and here's the unfortunate part, conventional biology is not a free science in the sense of free thinking. It is a funded science. You know, if I want to do research, I got to get some money. I say, well, yeah, but where's the greatest source of money coming from? The answer is the pharmaceutical industry. And I say, why is it relevant? Because when you get a grant from the pharmaceutical industry, you're almost essentially working for the pharmaceutical industry. And it biases the results. So the British Journal of Medicine published an article and said they looked at the results on the same research, but split it up based on whether the research was funded by public money or the research was funded by private corporate money. And the results are... The results were when private corporate money, like pharmaceutical money, was funding the research, the results were 4 to 5 times more in the favor of the funder than when the money came from public resources. So there's an internal bias. Where'd you get the money from? That also shapes how you get the results.
It absolutely, it's just been shown at this point, like you've got to question the research out there, which also throws the fundamentalist skeptic crowd into apoplexy because they only believe in double-blinded studies, but they're all only funded so it locks them into this weird chemical industry paradigm that is dysfunctional if you want to hack the human body.
It's 100% dysfunctional. It's in favor of the system. And people go, okay, look, bad drugs, illegal drugs are a problem in this world. Do you know how many people die from illegal drugs? And I go, 20,000 people? And they go, yeah, maybe 20,000 people die. And I go, and how many people die from taking prescription drugs? 300,000? And that's a true story. Yeah. We wage a war on an illegal drug, which takes off a minority of the population, and we legitimize a pharmaceutical industry where 300,000 people die from taking conventional prescription drugs, and we don't count that. It's like, oh, that's the cost of doing medicine. I go, it's damn expensive to do medicine.
It sure is. Well, you talked about the red laser thing. I started using low-level light therapy, lasers mostly because they didn't have enough LEDs back then in the late 90s. I fixed whiplash in 6 minutes with a red laser. I bought the laser, and ever since then, I've been using light as part of what I do is to heal. And people are like, what the hell are you doing? You have lasers and lights and you're a damned hippie. I'm like, whatever. Like it seems to work really profoundly.
You're a happy hippie if you think about it, right?
Exactly. I'm also I'm a Silicon Valley tech guy and cloud computing and all this pretty impactful stuff. I'm like, so whatever, I'll do what works, but I'm 100 pounds lighter than I used to be. So I'm okay with this. And I don't really care that I'm wearing colored glasses that filter the light that comes into my system because it's an environmental variable that matters. And
I had to tell you, it was the exact same thing for me because people say, well, you're off on that weird stuff. And I turn around and I tell you, my life on this weird stuff is so much better than when I was doing your conventional stuff. I wouldn't turn around. I'm staying out here.
Even butter instead of milk in coffee. There's science behind it. There's good chemistry science behind that and the brain octane and all that. But it doesn't matter. The number of people who are like, it's the end of the world. You're like, this is a tiny thing. Let's shine lasers at your coffee and see what happens, right? So I want to go back to what you said about the cells releasing light because that's something that I haven't talked enough about on Bulletproof Radio and just in general because I'm a little concerned that this is so powerful people will harm themselves. I bought a device in also it was about 97, 98. It was a very high-powered infrared LED. And it was used by its inventor to basically transform his brain. And the guy had so much of an effect from it that after 9 months of using it, he went back to medical school and deleted all information about his invention from the internet because he was afraid he was going to get sued, that's why I'm not naming him right now. If he's listening, and he probably is actually, he would know who I'm talking about. But I would use this thing for 2 minutes at a time on the back of my head, and it really changes your brain, in a very strong way. But I took it 2 minutes, okay? And I put it over the language processing center in my brain here on the left side of the head. Because I've never been able to hear French or Swedish. It sounds like someone chewing gum to me. Like I don't process sounds the way normal people do, so it's just hard for me to just make out the words. And after 2 minutes on that part of my brain, I spoke in garbled sentences for about 6 hours. I mean, like literally, I'm like, this is a bad thing. I don't like, okay. And eventually it went away, and who knows, it probably improved things. But that's how powerful light, that wasn't even a laser, that was an LED. That's how powerful light is as a biological signal to the body. And the mechanisms now, you talk about cell membranes. I'm looking very much at mitochondrial activation with these things, which seems to be the primary epigenetic medicine.
Which is also cell membranes, because the mitochondria works because of the cell membrane.
Because of the mitochondrial membrane, right.
Yeah, and it's just a symbiotic organism. It is living within our cells, and there's an exchange. So it's an intact organism, but about 90% of its genetics has been transferred to the nucleus of the parent cell. But it's still a free living entity in there with a membrane, and the membrane for any entity is really the control place.
And as I'm working on my new book about mitochondria, some of the little tiny details that I didn't understand, the mitochondria, they communicate with each other. Like essentially, we talk about we're a collection of cells. Well, inside all of our cells, in fact, inside your brain, there's 10,000 mitochondria in a cell, and they're all talking to each other and talking to the mitochondria in other cells. So like, are we a collection of bacteria that each has their own petri dish that are all inside a big petri dish? Is that a better model for what we are?
It's exactly what it is. The intelligence of a system is based on the surface area of the membrane. The more membrane, the more intelligent. Bacteria get limited because they are like invertebrates. They have a shell on the outside. So it says a bacterium can only acquire X amount of membrane. It can't get any more because it's controlled by the outside shell. And I say, oh, well, then in evolution, the first part was to make this really intelligent bacterium. I go, yeah, but then what? Well, the smartest bacterium could not get smarter because of a limitation on the ability to make more membrane because of the shell around the outside. So I said, well, then evolution stopped because evolution was making a more intelligent organism by adding more membrane, reaches the endpoint, says, I can't make the bacterium any smarter. I can't add any more membrane. So I said, oh, well, then evolution stopped. I said, yes, it did, but then it changed modality. The next modality was, since I couldn't make a smarter individual bacterium, then what happened was evolution said, what if you bring a bunch of bacteria together? And then they all share their information. I go, well, then you could get more intelligence, because if you're a member of a community, then you have access to all of the information in the community. So the next level of life, the first level, make the smartest bacterium. The second level was, after you got the smartest bacterium, bring them together in a community. And this was called a biofilm. And what it represented was a membrane-bound community of all different kinds of bacteria, not the same one, different ones, but they integrated their activities. Some were breathing oxygen and others were working without oxygen anaerobically. Some were doing this function, some were doing that function. What did they do? Inside that membrane, those bacteria created an integrated community, and it evolved to become what we call the amoeba. The amoeba is what? Well, a membrane-bound sac that used to be all the individual bacteria. The only one that still retains the bacterial configuration are the mitochondria. And I say, yeah, but so what is an amoeba? By definition, an integrated community of bacteria for enhancing the intelligence of the system. And I say, but now that we have an amoeba with a big membrane on the outside, we can make a smarter and smarter amoeba by more and more membrane, no capsule. I say, yeah, but it still reaches a certain size, because if the cell gets too big, it's like a balloon filled with a lot of water. If there's a little water in a balloon, we can throw it around. Nobody has a problem. But you put a lot of water in a balloon and try and throw it, the balloon ruptures, the water comes out. And I say, a cell membrane will rupture if it gets too big. I go, so the first phase, bacteria become the smartest they can be. Second phase, bacteria form a community, which then integrates and becomes an amoeba, which then the amoeba went through evolution to make the smartest amoeba, reached the maximum size, and go, stopped again? And I go, yeah, but then guess what? The amoebas came together and formed a community. I say, and what did that do? I say, well, 50 trillion amoebas are making this up. I'm a community. And I say, and what happens then? I say, well, then you fill out the brain until you can't put any more brain in there. And it's that, we're back to, I can't make a smarter human. I say, then what? I say, it's a repetitive pattern. Yeah. Once the individual organism reaches its highest ability, intelligence-wise, and can't get any more, the next level is to join up and make a community. And the evolution on this planet right now is the evolution that first we looked at ourselves as individual elements. And I go, yeah, but the evolution is we are cells in a bigger thing called humanity. Yep. And what we're seeing is the world going through crisis. What? Because we have separated ourselves. And the reality is, no, the evolution is coming together. So borders are breaking down. Politics is strange in every place right now, especially here. And I say, why? It's a breakdown of separation. And the internet is the evolution of a global nervous system that can integrate 7 billion human cells into humanity. So where are we? We're in an evolutionary upheaval. The old system is not sustainable, crashing, and the new one is just beginning to grow. Yeah. And your work for me is critical, and that's why I'm so honored to be here with you, because the knowledge is power. And we have been disenfranchised for a lot of knowledge, disempowered. And the only way to empower people is to send the messages out to the community. And so why I'm so excited to be here is, and you are an evolutionary leader, because you're bringing a public a new vision, and not just this is a nice idea. No, this is a scientific revision of our world. And so thank you for this opportunity, because as every person realizes they're an individual power, then if the people take back the power, God, the vast majority of people on this planet want the same thing. Peace and harmony, a job, food, place to live. They all want the same thing. It's only a small percent that's saying, screw everybody else, I want all of it. And it's like, when people get empowered, and you offer this, thank you, Dave, for doing that. When you offer it, they get knowledge. Knowledge is power. And that is our evolution, is not a physical. Human is not going to change. Human consciousness is the evolution.
You've said in some of your writing that humans spend 5% of the time in the conscious mind and 95% in the subconscious mind. And it seems to me that there's a way to put more energy in each of us human cells, in each person, by going down to the cellular level and hacking that. You change the environment around you. We've grown new mitochondria. A lot of my supplements are designed to support mitochondria. And even the ketones, just in general, you're in ketosis right now, is putting more electrons into your cells. You can do more as a member of a global community. And frankly, it makes us less assholic, if that's a word.
Oh, I've seen that in the pathology book, yes. Yeah, and it's so important, because we have had so much power, but our belief programming has been disempowering. And this happens for kids. First 7 years, who are you? You hear from your parents, well, you're not this, and you can't do that, and you're limited, and it's a continuous disempowerment. And so our subconscious programming, which, as you mentioned, is running 95% of the time, is programs that doesn't encourage our health and vitality. In fact, the majority of programs take away our power, our vitality, and our health. And so when we look at the illness on this planet, and we mention, hey, 1% is due to genetics, I say, yeah, then what's the vast majority of illness due to? It's not a frailty, it's not a vulnerability on the part of my biology. It is a problem in the information that I'm sending from my interpretation of the world to 50 trillion cells, preparing them to deal not with the real world, but deal with the world that I'm telling them exists. A liver cell doesn't know what's going on. The only way a liver cell can adjust its biology is the nervous system reads the environment and then sends a message to the liver cell, say, this is going on in the environment, we need you to do this. And I go, well, this is cool, except for the fact that if we look at the environment with glasses, filters, two people looking at the same environment don't see the same thing.
Exactly.
I say, yeah. But the point is what you see is translated into chemistry that controls the cell. So if you have a negative outlook, even in a most beautiful supporting world, your liver cell doesn't know it's beautiful and supporting. Your liver cell only gets the information your mind sent. And therefore, it turns out the health problems are not physical, biological in origin. The health problems are consciousness and limitation and disempowerment that makes us powerless. And in being powerless, we are frail and vulnerable.
The mechanism for the nervous system sensing the environment around you, that there's a psychological component where you tell yourself a story, the glass is half full or the glass is half empty. There's also an environmental sensing thing. And are you familiar with Douglas Wallace's work?
No, right now I can't say I do.
Oh, okay, cool. He's I thought you might have been. I wouldn't just randomly name drop there. He's been doing a lot of work recently on mitochondrial environmental sensing.
Yes.
And the very latest, this is just in the last, since 2013 really, looking at quantum biology and looking at how potentially they may be the mediator for how we sense the world around us. And then there's another mechanism, and one where I think you've spent a lot of your time, where there's this internal environmental sensor where you tell yourself a story about reality and that changes your cells. And then the cells sense, what kind of food is there? What kind of light is there? What kind of temperature is there? And that affects mitochondrial energy production via these light pathways you're talking about. And I can't say that one of the systems is bigger or more important than the other, but it seems like there's like external environmental sensors that happen on the skin, in the cells, without nervous system involvement. And then there's a nervous system involvement as well. Do you buy that picture of the world?
Well, no, I really keep the nervous system always involved, whether you're conscious or not conscious. It has to be what is interfacing the outside world with what's going on in the inside world. The inside world is there are drives to survive. And in biology, we call it the biological imperative. And the imperative represents the drive. Point. There's no organism that if you threaten to kill it, it'll go, oh, okay, kill me. Even a bacterium, when threatened, will try every maneuver possible to stay alive. And I say, oh my God, the most primitive organism has a drive to stay alive. And I say, yeah, we don't know how it works. It's called the biological imperative. And the biological imperative is the drive you need water, you got to have water. You need food, you're going to have food. So everything to keep the system alive is what you're looking for, okay? And so that drive requires a constant scanning of the environment to see if I should adjust something or do something, unconsciously to survive. I mean, if a ball is coming towards your face, you will wink your eye without, it had nothing, but it was a nervous system response, but it wasn't conscious, it had nothing to do with it. So a lot of the drives that control behavior are below consciousness. And as a result, we say, well, I didn't think about it, it just happened. And I go, yeah, but it's still a nervous system.
Right.
Because you must integrate 50 trillion cells. It's the only way a community works is everybody's informed as what's going on. So the function of the nervous system is to provide that communication. And even though you don't see it as a mental processing, I walk outside and it's cold out, my nervous system picks up on the skin, the temperature, and that's sent to the brain subconscious that says, oh, we better warm the body up because it's cold out. And I change my physiology to warm up. Or I walk outside and it's hot out. And I say, it's picked up by the skin, but the nervous system is interpreting that it's hot and says, oh, I must engage these things to cool you down. I go, the conscious mind had nothing to do with that. They're completely below consciousness.
Right.
Yet there's a nervous system. Something had to read the environment and then relay information about what was going on in the environment. And if you disconnect the nervous system from the system, then like in cells, the nervous system is the membrane, the skin, and it's just so people are, oh, weird, the skin is the nervous system. I go, if you understand human embryology, our nervous system is coming from the skin. Yeah. So we in the cells have a parallel understanding, and so on the cell's skin there are receptors, just like we have eyes, ears, nose, but they're molecular receptors, but the equivalent. Right. I go, why relevant? If you cut the receptors off, so there's no reading of the environment, the cell has zero behavior. It just sits there. It has no response. But once the receptors are replaced on the surface, then the cell engages in behavior. So what was the point? Behavior was elicited by the environmental stimuli. But if I couldn't read the environmental stimuli, then there is no behavior. So basically, it says, yeah, but the vast majority of our biology is controlled by direct environment, nervous system, cell, without consciousness being involved at all.
So without consciousness being involved at all, so some of the cell behaviors, say in your arm, the cells in your arm, here are happening at the cell membrane level in the cells in the arm, and then a signal goes to the mind, and then the mind changes the biology the way it's going to change the biology. But some of the biology may have just changed because, like, if you shine a laser on you, or like if you get a suntan, like the fact that you're getting melanin in your cells probably isn't because the signal went to the brain and then the brain caused you to release MSH to grow melanin. It's a local response, right?
It can be both.
It can be. Okay.
It can be both. You have to recognize both.
Okay.
Yeah, because if you say one or the other, then I'll give you an example, then you'll give me an example, and I go, well, how about both? Let's
I'm looking
accept
for
both.
validation of the both hypothesis.
Okay.
Okay.
Of course it's both, because I take the cells out of the system, disconnect it from the nervous system, put them in a Petri dish. They'll respond to the environment directly.
Got it.
Okay. But then the question is, as I said, the liver cell is inside my body. It's supposed to adjust its biology to match my needs, the drive to stay alive. And so the liver cell must have a reading of the environment for it to know what behavior it should produce.
Exactly.
So if you send the wrong information to the cells, then by definition, the behavior they engage will not be in sync with the world in which you live. And that is the foundation of disease, meaning you're organizing a cellular community to something that doesn't exist if it's just a made-up belief in your mind.
Yes.
And that's where the biggest problem comes from, because our world today is driven by leadership that knows that they can manipulate your intelligence by putting you in fear. And fear causes not only a physiological shutdown of my health and my biology and my immune system, but people don't recognize this, and they should, because election time is happening, and like one party out there is scaring the hell out of everybody, saying, hey, be afraid of every damn thing. And I go, whoa. I say, what's the relevant in that? And I say, when you're afraid, remember the stress hormones redirect the flow of the blood of the body to the arms and legs, because that's where you're going to have to use fight or flight. But they don't know this, most people, is that when the stress hormones are released in the body, the blood vessels in the forebrain, which is thinking, conscious intelligence, the stress hormones cause those blood vessels to squeeze shut and push the blood to the hindbrain, where fight or flight reaction is going to be rapidly controlled. So I say, what's the consequence of a stress hormone shot? I go, it makes you less intelligent, because now your behavior is not controlled by conscious processing and reasoning. Your behavior is now controlled by stimulus response, reactive reflex behavior. And it's unfortunate, because when people get into that mindset, shut down the consciousness, and they're in fear, all they want is somebody with a big stick to be in front and knock off all the bad guys. And then we have one presidential candidate says, I am the big stick. I will protect you. But scaring people first, and I say, well, what happens? Well, whether there's a real fear or not, if you scare somebody, their cells will not distinguish whether it's real or not. To the cells, it is real, because whatever chemistry the brain sends, that's all the cells can respond to. So if I scare you, then it becomes really important to know that that fear is ultimately going to cause a problem.
Very well said. I have one more question for you, and this is about cell membranes. And people listening are either like jumping up and down excited or going, why is he talking about membranes? But I'll try and provide some context for listeners. A guy named Gilbert Ling, who is one of the big fathers of looking at gels, a collagen gel, which is a big part of cellular biology, has done some experiments where he removes cell membranes entirely and has cells that still seem to function. And so we've all, at least I always believe that the little cell membrane made of tiny droplets of fat, what was fundamental to the cell, yet here's a guy who's removed the outer cell membrane and left the mitochondrial membranes intact and discovered that things still work. What implications does that have to you as a cellular biologist?
Well, the implication for me very much is that a eukaryotic cell, a nucleus-containing cell, the kind that the human body is made of, is filled with membranes. It's not just a membrane on the outside. There's all the organelles, every organelle. Go back and understand this. Every function of an internal membrane in one of these like amoeba-like cells, whether it's mitochondria, endoplasmic reticulum, Golgi, nuclear envelope, whatever, every one of those functions, where was that in the bacterium? And the answer was the outer membrane, because they only had one membrane. So all of the functions originally were on the outside, but through evolution, membrane was then taken to the inside to free up the outside. So then the thing is this, you might remove the membrane from a cell, but the cell has the ability to take the membrane that already is in there and recover itself again.
Right.
And heal itself. So there's an opportunity, a period of time where the internal membranes are still going to control the biology, but it must rebuild the outer membrane to stay alive.
And there's something kind of very cool happening in the collagen stuff inside the cell. But then we have these mitochondrial membranes, and these are so important. A lot of my own biohacks are cellular membrane biohacks.
Yeah.
The infrared sauna is changing water in the body. It changes cell membrane permeability. All the light stuff that I do, it changes the membranes for sure. But also, you take too much fish oil. What happens to the cell membrane?
Well, the idea is this. When you take too much of something, the system can get rid of anything it doesn't want. And that's why a lot of people take supplements and then they look in the urine and it's like, wow, look, I'm peeing out all of this stuff. And the answer is, well, you can only put in so much that it needs. Anything beyond what it needs is like, I'll store what I can, and whatever is beyond that, I'm going to get rid of it again. So the issue is you could oversupply, and yet the system is regulatory. It says if you put too much in, it will get rid of some of it.
Not as much in the cell membrane as I would like. What I've seen is you take like pharmaceutical level doses of fish oil, way more than you get in the environment.
Yeah.
It gets incorporated in the cell membranes to the point they become too fluid and dysfunctional. And you end up with like less functional cell physiology. But if you don't have enough DHA and EPA in your cells, then your mitochondrial membrane doesn't work very well, and you're walking around without enough energy. So there seems to be a sweet spot. And what it irritates me, my goal, by the way, is to have the most expensive pee on the planet.
Yeah.
I want my body to have every supplement, every molecule it could possibly use, knowing it'll get rid of the ones it doesn't want. But some of these things, like the oils, you take margarine, it gets incorporated in your cell membranes. You take fish oil, it gets incorporated in your cell membranes. But sometimes those changes are not beneficial, even though fish oil itself is kind of good. I'm concerned about that.
Yeah, that's a toxic interference. And the idea is there is a physical chemistry, which is at the bottom line energy, but it's expressed as physical chemistry. And if you distort the physical chemistry, you're going to distort signaling that goes through that physical chemistry, okay? So basically, it says that, well, that's why we look at the diet is so important. And to me, how important is a diet? And I go very simply understanding this, and that is that I grow cells in tissue culture. And the significance is I make culture medium. And I make the culture medium, and the significance about the culture medium is that it's representing blood. And then you say, well, Bruce, when you make your culture medium to feed your cells, where do you get the ingredients? And I go, not at Kmart. I only go for the best ingredients as possible because the life of the cell is based on these ingredients. And when we have a diet, when we don't realize, look, your diet is used to make building blocks for your blood. Why would you put toxic crap in there if you know that this is the most important element of communication and therefore eating less than healthy food? Farm, industrial farm food and that toxic crap like that is like, you are making culture medium. I would never put anything, if it wasn't the finest grade, into my tissue culture. Why? Because I can see the cells respond instantly. I put something that is not adequate in that tissue culture, and I could watch the cells automatically change their shape and start to get sick. And I was just like, yeah, well, if I'm doing that in a tissue culture, then in my skin-covered Petri dish, you can bet your life I'm going to make sure that I put the best ingredients in to make the best culture medium possible, and then that gives us the story.
Very well said. And in fact, if you just summed up kind of the entire first book I did about, like, what do you do before and during pregnancy to have the best, healthiest, smartest possible baby? It's that. Like, clean up the culture medium where you're going to grow a new cell or a new body.
Exactly. Exactly.
Yeah. Wow, what a powerful way of saying that. Thank you.
I appreciate it, and thank you again for letting me have opportunity to talk to your audience, to empower them, because we are so powerful, and yet we have been programmed to believe that we are not powerful. And that, I said, if that's what you believe, then you have lost your power. And so this is an opportunity to
It's true.
bring power back. Thank you.
You're very welcome. And I realize I've been a little bit derelict in my responsibility here because I wanted to talk to you about both The Biology of Belief, your first big book, which is incredibly groundbreaking, but also you have The Honeymoon Effect, your new book on relationships, which we haven't even talked about. So I'm going to have you back on the show if you're up
I
for
would
it.
love to come back. And that's a great one because that is a show of what happens. The story is very simple. Biology of Belief reveals that we have been programmed, especially during that developmental phase, first 7 years. And the relevance about that is what would happen if you get out of the program? And the answer is when people fall in love and they create for them heaven on earth, that is the actual expression for the first time in their life. They're not playing the program. It's taking the red pill, according to the Matrix, and getting out of the program. I say your regular everyday struggle life is the program. But the moment you fall in love, all of a sudden you're not playing the program. I say, yeah, and what happened to the struggle? It disappeared. And all of a sudden everything was beautiful. And so it says, well then the program becomes important to understand, and I would love to come back and have an opportunity to talk about that with you.
Well, I will make that happen. It might be a little while. And if I go to the Bay Area on occasion, I used to live there for 20 years. So if I can interview you live, I will. I always love getting a chance to interview people live. Either way, we'll do it.
I would love to do it. Come down and visit me here in Santa Cruz. It would be great.
I used to teach at UC Santa Cruz, so that'll be
okay.
fun.
I'm in the neighborhood, so come and visit.
Awesome. And one more thing before I let you go for today. If someone came to you tomorrow, Bruce, and said, look, I want to be better at everything I do in my life, like I want to kick ass at everything, what are the 3 most important pieces of advice you have for me? What would you tell them?
Well, I tell them number one is that the greatest limitation we have of the programming, which is disempowering, and child psychologists and developmental biologists will reveal that this programming is indeed about 70% negative, self-sabotaging, and limiting, and that the first thing is this: recognize the program and change the program, because that's how you can get your power back. Number 2, learn to live in harmony in your environment, because that's what evolution is all about. Evolution is not competition, evolution is cooperation. And therefore, we as a civilization have been antagonistic in our behavior to evolution because it's all based on competition. And lastly, recognize that love is probably the greatest healing agent on this planet. The vibration of love is wholeness and harmony and health. And so being in love is really great.
Very, very well said. Wow. What an amazing conversation we've had. And I'm not surprised, given the disruptive nature of your work and how you've been vindicated over the last, I'd say, 20 or so years. Like you were right. You stuck to your guns. You pissed off a lot of people. But look, epigenetics is as real as anything else. And you have way more power knowing about it and using it than you do just sitting around going, well, I guess I have these genes. I'm screwed. So on our next interview too, we'll touch on the fact I just had my own stem cells injected into my brain prophylactically. So we can touch about that. I'm going to be talking about that at the Bulletproof conference this year, and I'm really hoping I can get you as a speaker for the conference the year after that. So Bruce, thanks again. Have a wonderful day, and I look forward to having you back on the show.
Thank you so very much, and thank everybody in the audience for listening, because all of you are the cultural creatives that are making a big difference in our world. Evolution will come from you, so thank you.
Did you know that Bulletproof is on Instagram? You can find us at Bulletproof Coffee, or my personal feed is dave.asprey. Hope to see you there.